Hi everybody, this will be the minimum spanning tree for the reverse delete algorithm. We will begin to run through with the process of this accordingly. So we'll just have to work on this step by step. So for reverse delete algorithm, it is like a crisscross algorithm. However, you will begin to arrange it in a high with a high value format from the or it could be arranged in descending order for those weights. Now this will become like this. Weights, and then the vertex source, then the vertex destination, and then the action. So our goal here is to delete the specific higher nodes. So our goal we have here 40. Let's try to base it in here. Could you better that you will let me just go ahead and copy so that we can easily work on this. So um So 40, then 29, then 23, then 20, then 15, then 13, then 12, then 10, then 9, then 6, 5, 3, 6, 5, 3. So therefore, those are the um number in descending format. So the vertex source that we do have pertains to that. Let me just go ahead and make a label here. Okay. Sorry, I'm not trying to work here using any ruler. Sorry, because I'm in a hurry. Now, in terms of this 40, where will be the vertex that is came from? That's fine if J to H or H to J. That's gonna be that's still fine because this is bidirectional. 29 is actually H to I. 23 is J to I. G to I mean. 20 is E to I. And then 15 is F to G. And then 13 is where is 13? Can't see it. Okay, I to J. And then 12 gonna be E to F. Then 10 will be F to H. Then 9 will be D to F. And then 6 gonna be um D to E. And 5 gonna be A to H. Then 3D to G. So our goal here, we do have certain action. We're gonna do, we have to delete such cases. So H to J, if we begin to delete H to J, does that disconnect the does that create any disjoint set? If it will become disjoint set class, when we say disjoint set, for example, there will be K here and that is not connected to H, that is considered disjoint. That is the thing that we have to avoid here. So if that will not be a disjoint, so therefore it's okay that um we'll just keep as is, okay? Now, first is H to J. Now, if we will begin to remove F to J, does that create any does that disconnect or disjoint the set? No, it will not. So H to J, we can delete that one. So H to J, we can delete. So that is 40. That is for the step one. So just make sure to check for the step two. H to I. So we just have to copy. Okay. H to I, let's try to check for H to I. If that will disjoint. H to I will not. So it's fine. We can remove it. So therefore, our action will become check. Then G to I, that is 23. Let's try to walk. Let me just go ahead and create here as separate steps. So let me just copy. Afterwards, it is G to I. So G to I does dot, does this disjoint the sets? No, it will still be, everything will still be connected. So therefore, we can definitely perform the deletion effectively. So E to I will be the next one. Let's try to see for E to I. Let me just copy the resulting three that we were able to have earlier. So number 4, E to I. When we remove E to I, this dot, I'm so sorry, let me just fix this. This is E. Okay. All right. So if we'll begin to remove this securely, this E to I, what will gonna happen if E to I? So E to I is um E to I. So therefore, sorry, E to I. No, that's not E to I, 20. F to I. F. My goodness. That's F to I rather. That's not E. That's F. Okay. F to I. So F to I, if you will remove 20 here, it will gonna be disconnected. So therefore, we can't do anything, okay? So F to G, if if you will remove F to G, for step 4, no changes there. It's okay that you will not begin to draw. F to G is 15. So therefore F to G is here the if we'll begin to delete that one, it will be connected, so that's fine. We can delete that. So therefore, you can only just draw class those checked element only. Okay. Now I to J, which will be 13. I to J is 13. If you'll remove that one, it will be disconnected. So therefore, we cannot remove it. 12 E to F. E to F. Okay, let's go ahead and perform another. Let's review. Okay, just give me a second. Right then. So the next will be E to F will be 12. E to F 12. If we'll remove that one, it will still be connected. So therefore, that's fine. We can delete that. So it will be checked here. Then 10 F to H. F to H for step 6. F to H. Okay, number 6. Let's try to check. Okay. All right. So copy as is. And then afterwards, mm-hmm. All right. All right. So in our step 6, I'm sorry, I'm actually checking my messenger. Someone is actually messaging me. Now here then the certain step 10 is F to H. Once we will remove F to H, um F to H is here, so therefore it's fine because it will be still connected to each cases can still be connected. So therefore, this action will be checked here. And then D to F, checking D to F. So it will be disconnected, so therefore wrong. Now D to E, um, D to E, no, we cannot remove that. E to H, so we cannot remove still. And D to G, we cannot remove it then. So therefore, um, okay, so this will be the minimum spanning tree. So 6 plus 9 plus 3 plus 5 plus 20 plus 13. So it's gonna be still 56, right? So since we're able to have it the same thing earlier. So that's this is actually the steps for reverse deletion. I mean the reverse delete algorithm. I hope hopefully that you were able to understand it well. Thank you so much, everybody, and I'll begin to also post another video for the shortest path technique, which I'll begin to discuss dealing with the Dijkstra's algorithm and Bell-Manford algorithm. Then afterwards, I'll begin to discuss also the sorting technique, specifically the bubble sort algorithm, insertion sort, selection sort, and then so on and so forth. Thank you so much, everybody, and goodbye for now.